Did you know that the fastest speed in the universe isn't the speed of light, but the speed of time? Now imagine if you could control that speed. Welcome to the intriguing realm of time travel, a concept that, while firmly lodged in the annals of science fiction, is based on the fascinating idea of time as a dimension. Just like length, width, and height, time is a dimension we exist within. But imagine if we could manipulate it as we do the other three. Could we move forwards and backwards in time just as we do in space? This concept has fired up imaginations worldwide, spurring countless books, films, and TV shows. It's become a cultural touchstone, a shared dream of humanity, a symbol of the limitless potential of our minds. So could time travel ever become more than just a science fiction dream? Let's delve into the physics of our universe to find out. When you think about time travel, it's easy to get lost in a maze of paradoxes and impossibilities. But in the realm of physics, nothing is impossible, just highly improbable. To understand time travel, we first need to grasp Einstein's theory of relativity. It tells us that space and time are not separate entities, but are interwoven into a four-dimensional fabric known as spacetime. This fabric is flexible, and massive objects like stars and black holes cause it to curve. This curvature creates what we perceive as gravity. Now imagine if we could manipulate this curvature. We could, in theory, create shortcuts through space-time, known as wormholes. Imagine space-time as a piece of paper. If you wanted to get from one side to the other, you could go the long way around, or you could fold the paper, bringing those 2 points closer together. That's essentially what a wormhole does. But creating and stabilizing a wormhole is far from simple, and it would require a form of negative energy that we're not even sure exists. Then, there's the idea of the warping of space-time around black holes. The intense gravity of a black hole can slow down time. If you were to orbit a black hole at a safe distance, time would pass more slowly for you than for someone far away from the black hole. This is known as time dilation, and it's been proven by precise clocks on GPS satellites. But with the excitement of these possibilities comes a heap of challenges and paradoxes. One famous example is the grandfather paradox. If you could travel back in time and accidentally prevent your grandparents from meeting, you would never be born. But if you were never born, how could you have traveled back in time in the first place? It's a mind-bending conundrum that has yet to be resolved. Time travel might seem like a far-fetched idea, but the universe is full of mysteries waiting to be unraveled. Who knows? One day we might just crack the code. So, if time travel is theoretically possible, what does that mean for our future? Could we one day hop into a time machine and journey to the past or the future? Now that's a tantalizing thought, isn't it? Imagine the potential. Historians could witness crucial events firsthand. Archaeologists could explore ancient civilizations in their prime, and doctors might even be able to study diseases at their inception. The knowledge we could gain is mind-boggling. We could learn from our past mistakes in real time, or foresee future triumphs and pitfalls. But as with any revolutionary concept, time travel isn't without its potential pitfalls. Traveling back in time could risk altering the timeline, creating a ripple effect that changes the present in unpredictable ways. It's the classic butterfly effect. The idea that the flap of a butterfly's wings in the past could cause a tornado in the present. And then there's the paradoxes. What happens if you go back in time and prevent your own birth? It's enough to give anyone a headache. On top of that, there are ethical questions to consider. Would it be right to change the past, even if it could make the present better? And who gets to decide what changes are made? While we may not be packing our bags for a journey through time just yet, the possibility of time travel opens up a universe of exciting, mind-bending possibilities. In just a few minutes, we've journeyed through the fascinating world of time travel, from its roots in theoretical physics to its potential future applications. We've delved into the paradoxes, explored the physics behind wormholes, and the warping of space-time around black holes. We've even dared to dream about what future exploration might look like. Time travel may remain in the realm of science fiction for now, but who knows what the future holds. After all, in a universe where time is just another dimension, anything is possible.